All right, now we are into page 4, our fourth problem here. Again, no calculator, and we're into the 2002 test. Again, you can find all kinds of free response practice if you just search online. It's all available on College Board's website. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of T plus 1 gallons per minute for this time period. Remember, that is leaking, so we're going to have to make it negative at some point because square root of T plus 1 will not calculate to be negative on its own. All right. And at time 0, the tank contains 30 gallons of water. Okay, so how many gallons of water leak out of the tank from time 0 to 3? Now, I'm not going to force this answer to be negative. I will just be saying this is the amount leaked. Okay, so we need to find the number of gallons leaking out, we need to integrate the rate at which it's leaking. So the integral from 0 to 3 minutes of the square root of T plus 1 dt. Right? Because that's our leakage rate. Yes. Okay. What does that equal to? So now this is technically a U sub, right? U is T plus 1, but du dt is just 1. So there's not really any adjustment that we need to make. So you could do, the integral of square root of u, but that's really not necessary. So let's just go ahead and integrate. So we have T plus 1 to the 1/2. When we add 1 to that, we're going to get T plus 1 to the 3/2. And then instead of dividing by 3/2, I'm going to say multiplied by 2/3. We're going from 0 to 3. So I didn't officially use U sub here, so I'm not changing bounds or any of that. Okay, make that actually legible here, not needed. Okay, and then we need to evaluate. So this is 2/3. And then when we plug in 3, we're going to get 4 to the 3/2 minus 2/3 times 0 plus 1. So 1 to the 3/2. 4 to the 3/2, remember to root first. So square root of 4 is 2. 2 to the 3rd is 8. So this is now 16/3 minus 2/3. So I'm getting 14/3, and I want to label that as gallons leaked. You don't want to say negative 14/3 because it's just asking for the amount leaked. So, okay, so that is my solution for part A. For part B, how many gallons of water are in the tank at 3 minutes? So we need to think about, you don't have to call this a function, but I want to call A of t like the amount in the tank. Okay, so I just like to have something to work with here. So, okay, so let's call it A of t. So how much is in the tank? So remember, you're starting with 30 gallons. So you're starting with A of 0, and you're adding to that the amount of water coming in from 0 to 3 minutes. The water coming in is just a constant 8 gallons per minute. So I'm going to call that dt. And then there's also water leaking out. So we also need to say there's water leaking out. So we're going to subtract the integral from 0 to 3 of, square root of t plus 1 dt. Remember, we just found that answer, so you don't have to do the math all over again. So we're starting with 30 gallons in. What's this going to be? Remember, just a constant is going to be 8t times 0 minus 3. Or not times 0 minus 3, times 3 minus 0. And then minus, I already got this answer, was 14/3. Or you could use geometry here. This is just going to be 8 times 3. This is just 24. So 24 gallons get added in, but 14/3 gets subtracted out. So that's 54 minus 14/3. And honestly, you can just leave it like that. If you don't like that, then this is not too bad to say, okay, let's multiply 54 times 3. It's 12. That's 15 plus 1. That's 162 over 3 minus 14 over 3. So I'm getting, what is this? 148 over 3 gallons. I like to think that we can all do this math, but if you feel like you're going to make a mistake or if you're pressed for time, you could circle this answer. I think that would be okay. All right. And then on part C, write an expression for, oh, there we go, A of T. That must be where I got that. The total number of gallons of water in the tank at time T. So here's the nice thing about setting it up the way we did in part B. We just need to make some adjustments. So, okay, A of T. So be careful here. It's equal to A of 0, which is 30. Or you could write A of 0 right there, plus the amount of water coming in. So it's not going to be 0 to T. Or no, sorry, it is going to be 0 to T because I want this to match. But I want to make this 8 dx or something. Like this is kind of a technicality. But if I want to have T here, I want to have a different variable here. Or you could also just say plus 8T. Like that's totally fine, right? We just did 8 times 3. Okay, whatever. Either way is fine. And then you're subtracting out the integral from 0 to T of, don't make this square root of T plus 1. Give it some other variable. I'm choosing X. Normally we have it the other way around. When this is X, this is T. But I want the T here, which they gave me, to match what would get plugged in when you do the derivative. All right, so that's the answer to part C. Okay, and then for part D, at what time on 0 to 120 is the amount of water at a tank at a maximum? So, sorry, I don't know why I keep hitting that. Okay, so this is extreme value theorem. Remember, you need to list out the candidates. The candidates are, for times, are the endpoints, and we're looking for maximum amount. So we're looking for max A of T. So the endpoints are 0 and 120. And then are there any relative maximums? So where would the relative max be? That would be when A prime changes from plus to minus. And so we first need to figure out when A prime is equal to 0. So what is A prime? Let's see. Take the derivative of this up here. You get A prime of T would be equal to 0. And then plus the derivative of the integral cancels the integral out. So you would get just 8, right? Because there's no T to plug in there. So derivative cancels out. You just get 8. That's the rate that water's coming in. And then what about this? It'd be minus. And this derivative would cancel out the integral here. You would sub a T in here. So square root of T plus 1. And that'd be multiplied by 1 technically. We don't need to write that. So all this is saying is the amount coming in minus the amount leaking out is going to be what our rate at which the amount in the tank is changing. So we need to set that equal to 0. I'm going to add square root of T plus 1 over here. I'm going to square both sides. Remember, this is all non-calculator. And so I'm going to get T equals 63. So 63 is another candidate. All right. Now, let's think about this. It says, where is the amount of water at a maximum? So at 0, we know it's 30. Okay. And then there's going to be some point where the amount coming in is going to overtake the amount leaking out. Like it's coming in faster than it's leaking out. So we can find these other values if we want to. Let's see. So A of T... A of 120. I'm not sure if it's necessary. I think we could probably puzzle through figuring out our different values, but let's just go through this. So 30 plus, it's going to be 8 times 120 minus what did I get for this integral? This was 2/3 times 121 over 3 to the 3 halves. Oh, no, not over 3, sorry. To the 3 halves, and we're evaluating that from 120 to 0. That seems extreme, right? Okay, and then I'm going to finish that math later. Let's look at this. A of 63. That would equal 30 plus 8 times 63. And then we're going to have, I'm just thinking through like the math on this so I don't have to really crunch numbers. It would be 64 T plus 1 to the 3 halves, going from 0 to 63. Oh, I plugged in numbers too fast, didn't I? Gosh. T plus 1. All right, so do we really need to crunch these numbers, or could we think about this? Let's see. So if I'm plugging this in, 8 times 120 is a pretty big number, right? This is 30 plus, this is going to be 0, 16, 960 is 2/3 times, let's see, 121 to the 3 halves, which is like 11 to the 3rd power, right? And then minus 1 to the 3 halves. If you're taking 2/3 of that, you're definitely getting like something less than 960. So this is definitely going to be a positive number. And then here we're going to get, so let's see, 2/3 times 64 to the 3 halves minus 1 to the 3 halves. 8 times 63. Now this is only at, let's see, 420, 504. And then we're going to subtract this value. This is definitely going to be smaller than this value. Okay, but let's see. We're looking at when the amount of water is at a maximum. Yeah, so I think that at 120, well, no, let's see. At 63, that's definitely our relative maximum. And then if the rate is changing to negative, maybe I've done too much math here. If the rate is changing from positive to negative, we definitely have an A of t graph that increases and then starts decreasing. I think that's where, yeah, I'm definitely doing too much math. Let me get this out of here. Doing all that math seems pretty terrible and didn't feel right. So think about your A prime graph and what is that telling us about A of t? So we just figured out, okay, there's a critical number at 63. So A prime is 8 minus square root of t plus 1. So you're getting a positive if you plug in, say you plug in 0 to the left of 63, right? You're getting a positive 8 minus square root of 1. If you plug in something after 63, like let's plug in 99. 8 minus square root of 100 is 8 minus 10, so that's negative. So the A of t graph is increasing and then decreasing. So A of 120, A of 63 definitely has to be larger than A of 120. It doesn't ask me to find those actual values, so it just says at what time. So I really don't think we should waste time or risk a mistake in calculating what those actual numbers are. So I am going to say, all right, I need to justify this, I'm sure. So I'm going to say the max amount of water is at t equals 63. Are these minutes? Yes, 63 minutes, because A prime of t changes from positive to negative. And I'm going to say and never increases again. And A of t never increases after 63. So the amount in the tank is just leaking. It's not increasing as t gets bigger. All right. I think that's good enough for that one. Sorry, I kind of took you down a rabbit hole on part D, but I want to leave that in there because we sort of get into these habits of like, oh, I just always do this, this, and this. And when it seems really cumbersome to make a calculation, you should pause and think about like, is there another way I'm supposed to be thinking about this? So I'll leave that all in there.